use few more types, starting with the complex type and then the hexadecimal type and binary types. To define a complex type, you define a variable is equal to 3 plus, let's say, 5j. This is a mathematical algebraic expression. So use complex types to represent expressions or equations like this. Print the value of d, print d. Run the program and it will display the expression for you. To check out what type it is, print type, use the type function, pass it d, rerun the program, and it is of type complex type. It is an object of a type called, or a class called complex, which is an inbuilt class. To define a binary type, E is equal to, let's give line spaces so that it will be clear. So we have integer types, then we have floating point types, we have defined complex types. Now we are going to define binary types. A binary literal value starts with 0, B. B for binary, it could be capital or small letter, 1010. Now if you print it, save it, print E. That should print the decimal value of the following binary value or the integer value of the binary value. Rerun the program and the value is 10. So 1010, when this binary value is converted into an integer, it will be 10. Similarly, f is equal to define a hexadecimal literal, you use 0x and define a value f for hexadecimal, print f. Let's see what that value is. Run the program and it is 255. So when this ff is converted from hexadecimal to a number, it will be 255. And I'm going to leave you with an assignment to convert a octal number. You'll use 0O to define a octadecimal. So use 0O, define a number and print its value. Here you can know the type by using print type of E. Similarly, print type of f. Save it, run the program, and it's of type int, because when you print it, it's automatically converted to type integer. But when you defined it, it is of type binary and hexadecimal here.